My YouTube viewers, it's Crystal here. So what I've done in this video is I have entered Kaggle's playground competition, and so I just said play 6.2, but I should have said RFC because I use random forest classifier on this particular competition. And so it's Season 6, Episode 2 for February in Kaggle. And so the thing is that, I wonder if they'll let me, it says edit title. So I've edited it to make it 6.2 RFC. So that lets you know it's a random forest classifier. And then, so what I've done is, what I'm going to do is I'm going to review the code of this competition that I entered yesterday. So I think it was, today's Wednesday, so I think it was on Monday that I started working on the code. And I must have finished it yesterday because I had some things to do, and because I had some things to do, I couldn't do it all in one day. And so I started it Monday, and I finished it Tuesday, yesterday. So the first thing we're going to do in this competition is we're going to define our problem statement. So we're going to calculate our heart attack risk, calculate the probability that somebody is going to have a heart attack. And I find this particularly interesting because I have a lot of health problems, and I've just recently been told that my coronary artery is mildly calcified and I'm going to have to take statins, although I'm not taking statins this very minute. And the reason why is because I have to send an email to my doctor's surgery every month to get my medication. And the last email I sent, I forgot to put the statins and the vitamin D in there. But on the most recent email, when I realized what I had done, the most recent email that I sent, I made sure that I included the statins and the vitamin D. And because I'm not in good health, I have like 10 medications that I have to take every day. And in addition to that, I also get a the little strips for the blood glucose monitor, and I get the Lancets for the blood glucose monitor as well. So I don't have to pay for those. I get those on a prescription, just in case you were interested. And so it's interesting that I'm calculating a heart attack risk because I have a calcified coronary artery. I am at risk of a heart attack. So the first thing that we're going to do in order to write the code for this program, and we've written it in Python, is we're going to import the libraries. So the libraries that I'm importing in this instance is Pandas as PD. That's going to create your data frames and process the data. NumPy is NP, so that's going to create NumPy arrays and perform numeric computations. OS, which goes into the operating system. I'm going to import sklearn, which gives you machine learning functionality, and matplotlib.pyplot for visualization, and also seedlearn for visualization. So after I have imported all my libraries, then what I'm going to do is I'm going to use OS to retrieve the files that I'm going to use in the program, and the 3 CSV files that are called up are test, train, and sample submission. And all 3 are CSV files. And so what we want to do is on these CSV files, we are going to convert them to data frames using pandas. And so when we convert them to data frames using pandas, we want to make sure that we are able to see all of the columns. And so we do pd.set option brackets display.max columns, comma, none. And so that means that you can display all of the columns, and so you don't have to worry about only seeing part of them. And then we're going to convert the CSV files to a data frame using pandas. So train equals pd.read CSV brackets, and then we have the web address for train, and then for test, and then for sample submission. So we're going to look at train, and train is the data frame that we now have, which has 630,000 rows by 15 columns. So you're going to have your ID, that's your identification, your age, your sex, your chest pain type, your BP, that's your blood pressure, your cholesterol, your FBS over 120, I don't know what that is, your EKG, that's a test of your heart, your max HR, I don't know what that is, your exercise angina, your ST depression, I don't know what that is, slope of ST, I don't know what that is, and theft film, I'm not sure why they use that. And then so it's going to tell you whether or not you have heart disease. So it tells you whether you've got a presence or an absence of heart disease. So a presence is a 1, going to be 1, and absence is going to be 0. So we want to see what kind of columns we have. So all of the columns are numeric columns, and ST depression is a float. So that's a whole number, whereas the rest of the numbers are integers. So we check to see if we've got any null values in the train set, and no, we do not have any null values. So test is the same format as train, except you don't have the final column of data, which is your target. So the final column of data tells you whether you have heart disease. You don't have that in the test file, and so basically what's going to happen is you're going to be predicting on that. So you're going to have 270,000 rows by 14 columns. So the train and the test file combined are 1,000,000 columns, so that's a lot of columns of data. So we check the info of the test file, and the test file is the same format as the train file. We check to see if we have any null values in the test file, and no, we don't have any null values. So we look at our submission file. So your submission file is telling you how Kaggle wants to see your submission when you submit your work to them. So that's just giving you an idea of what they want to see. So because we're using pandas, you don't need to have an ID column, and the reason why is because pandas automatically indexes every row of data. And since pandas automatically indexes every row of data, the ID column is redundant. So we're going to drop the ID column from both the train and the test set. So now instead of 15 and 14 columns of data, now you're going to have 14 and 13 columns of data. So we're going to analyze the target. The target is the final column of data in the train file. So target equals train.pop heart disease. So we're going to pop the heart disease column out of train. So now the heart disease column is no longer in train because you popped it out. And then what we're going to do is we're going to use Matplotlib to create a histogram of the target. And this is the histogram that we have created. And so since it's a classification of 2 categories being absence and presence, you're only going to have 2 bars, 1 bar for presence and 1 bar for absence. So you're going to have less rows of data that are presence than you have on absence. So now we're going to encode the heart disease. So target equals target.replace, brackets, absence becomes 0 and presence becomes 1. And then so also it gives you a little message telling you that replace is deprecated and will be removed in a future version. So at some point I'm going to have to start using something other than replace, because at some point they're going to remove replace and it just won't work. And so you need to be aware of that. But so we've got the target now. So now instead of absence and presence, we've got 1 and 0. So you can see on row number 0 is a 1 and row number 1 is a 0. But if you go back to the train data frame, you'll see presence and absence. So presence is 1 and absence is 0. Which was what we got. Presence being 1 and absence being 0. So now what we're going to do is we're going to analyze the train data frame. So what we're going to do is we're going to create it says num small calls equals an empty list. And for call and train, that's column, if train call dot unique bracket is less than 6, colon, num small calls dot append call, and you print num small calls. And then so you're going to do is you're going to print out all of the columns that have unique values of less than 6. And then we're going to use matplotlib. We're going to create a for loop for call and num small calls. Counts equals train call dot value counts. And then we're going to use matplotlib to actually create a bar plot for every column that has unique values of less than 6. So plt.figure bracket 6 fig size equals 6, 4 counts dot plot brackets kind equals bar, color equals steel blue. plt.title is distribution of call. plt.x label is call. plt.y label is count. plt.type layout and plt.show. So you've got your distribution of sex. So you're going to have 1 is larger than 0. So I'm just going to assume that males are 1 and females are 0, but you never can tell. You never can tell. And then we're going to have distribution of chest pain type. So you've got chest pain type from 4 to 1. You've got distribution of FBS over 20. I don't know what that is, but that gives you a distribution. You have distribution of EKG results. So you have 0, 2, and 1. I don't know what that is. You have distribution of exercise angina. So it's going to be 0 and 1. You have distribution of slope of ST, and you're going to have 1, 2, 3, but I don't know what slope of ST means. You have distribution of number of vessels, fluoro, and again you have 0, 1, 2, 3, but I don't know what that is. You have distribution of thallium. Thallium is some mineral, I think, that's in your body. And you have 3, 6, 7, but I don't know what that is. And then now what we're going to do is we're going to create a histogram of all of the columns that have unique values greater than 5. So num large calls is a blank list. For call in train, if train call dot unique brackets is greater than 5, colon num large calls dot append call, print num large calls. So the number of columns that have unique values greater than 5 are age, BP, cholesterol, max HR, and ST depression. So we create a histogram, or we create a histogram of, well, actually it's a bar chart, but it looks like a histogram. We create a bar chart for all of the values that are the unique values greater than 5. And so we have the distribution of age, we have the distribution of BP, we have the distribution of cholesterol, we have the distribution of max HR, and we have the distribution of ST depression. And so that is it's a bar chart as well. It's not a histogram, it's a bar chart. So what I might do after I finish this video is I might go ahead and change it from bar chart to histogram and see if that improves the visualization, because I thought that I was going to make it as a histogram, but whenever I was trying to work on the code for this, somebody came to my house and he has a learning disability and he doesn't really fully comprehend that I have to work. So I was trying to work on this while I was talking to him. But I think what I might do is take this and convert it to, rather than a bar plot, I might convert it to a histogram and see if that works better, and then see how that turns out. So now what we're going to do is we're going to define our dependent and our independent variables. So Y is your target, X is your train, and X test is your test data frame. And so what we're going to do is we're going to split the data set into training and validation sets using sklearn's train test split. So X train, X val, Y train, Y val equals train test split, brackets X comma Y comma, test size equals 20, random state equals 42, and then we're going to print off all the shapes of these 5 data frames. So we're going to define our model. So model equals random forest classifier, max depth equals 2, comma, class weight equals balanced, comma, random state equals 42. We're going to fit the X train and the Y train, and we're going to score the X train and the Y train. So we have an 87% accuracy on that. So now we're going to predict on X on the validation set, and it's going to give you zeros and ones. And then we're going to use matplotlib to take YPRAD, which is the prediction, and we're going to create a histogram of that. And you can see that, again, you've got 2 columns of your histogram. And the reason why, one thing that I found was a bit odd, is you have more zeros, which is an absence, than you have ones, which is a presence. So let's go back here to the histogram of the target. So yeah, so you got more presence, which is a 1, than you do absence. So you have more zeros, which is absence, than you do presence. So that's interesting. So that's just letting you know that it's working. And then now what we're going to do is we're going to use the predict propa command to print off the probabilities. And the thing is Kaggle was using the AUC, the metrics AUC, to score the competition. So that's why you had to use AUC equals metrics.rock AUC score, and we get AUC score of 0.94. And then what we're going to do now is we've got a histogram of widespread proba, so you can see what that looks like. Okay, now we're going to define our feature importances, because one good thing about random forest is random forest allows you to determine which features are more important than others. So importances equals model.feature importances, feature df equals pd.dataframe brackets feature is x columns, comma, Gini importance is importances dot sort values brackets by Gini importance, comma, ascending equals false. And you can see feature df. So thallium is the most important feature. Thallium is the most important feature, and BP and FPS over 120 are the least important features. Well, that's what Random Forest has decided anyway, but I know from having been to the doctor, they never said anything to me about thallium. I know it's a mineral or something, but I'm not sure. But I know BP is your blood pressure, and so yeah, blood pressure is really important. So maybe in this particular instance, although Random Forest is saying BP isn't very important, when you go to the doctor, one of the first things that they want to do is check your blood pressure. So I think that BP should be important, and the cholesterol should be important as well. And the reason why is because the doctor told me that I have high triglycerides, and people with high triglycerides have a higher risk of getting a heart attack. And so that's why they said that they wanted me to take statins for that purpose. So that's just something to think about. So now what we're going to do is we're going to use Matplotlib to actually create a bar chart of the feature importances. And so whereas the data frame gave you the numerics, letting you know that thallium was the most important feature and BP and FPS over 120 were the least important. When you create a bar chart, I created a horizontal bar chart in this instance. You can see it visually, and in addition to that, I also created some colors. So colors equals plt.cm.tab20 brackets np.linespace brackets 0, 1, len brackets feature df. So that's generating colors, and so each each horizontal bar is actually a different color. So that's just something that I made. But these are the features that Random Forest has said are the most important. But if a doctor was to see this, they might disagree. They might say, oh no, your blood pressure and your cholesterol are really important too. So this is just something that I created just to give you some more bells and whistles. But I definitely would be interested in finding out what a doctor would think about the feature importances, how a doctor would rate him. And I certainly think that you should go with the doctor's opinions more than you should go with random forest. And so that's another issue about AI. So we are using AI. I mean, we're not using a large language model like Copilot or ChatGPT, but we're still using AI when we make predictions on whether or not somebody's at risk of a heart attack. So that's another reason why you need to fact check your predictions. And then so, because AI doesn't always get it right. Now, Random Forest is saying that BP, blood pressure, and FBS over 120 are not important, but I do know every time I go to the doctor, they check my BP, so I think BP is important. So you need to fact check. So let's say if you're doing some work, if you're doing work on heart attack risk, I mean, ideally, you would need to have a little bit of a background to understand the importance of all of these features. And then if you understand the importance of all of these features, that would give you a better idea whether to determine whether they're important or they're not important. So that's just something to think about, and just something that I found in this competition. So now, after we have predicted on the test set after we predicted on the validation set, what we're going to do is we're going to predict proba on the test set, and then we're going to create a histogram of the predict proba, the pred, on the test set. So we've created a histogram of that. And then when we've done that, we're going to prepare our submission. So submission heart disease equals pred proba, submission.tocsv, bracket submission.csv, comma, index equals false, submission equals pd.readcsv, submission.csv, and then submission. And so these are the values of the heart disease column of the submission data frame. And then these values give you the probability that someone is going to have a heart attack. And whenever I submitted my work to Kaggle, I got a 94%. So that was pretty good. It wasn't top. I didn't get top, but it was pretty good. And I also got a bronze medal out of it. So that's pretty good for my first attempt at the competition. But I think I'm going to go back and convert some of the charts to histograms, or see how, if I get on better, if the histograms give a better reading, because the other charts, I don't know, it looked almost more like a Pareto chart than anything else. So maybe a histogram would give you a better distribution or more understanding of the distribution, which is what I had intended to do. But because I had someone with a learning disability talking to me, not really understanding that I needed to work, I didn't do that. But I still got a bronze medal even though I didn't do that. But I'm going to go back and change it to a histogram and see what happens. So that concludes this video. If you like my video, please like and subscribe. And I will be making more videos for you regarding data science very soon.